All right, we are going to review what finding a zero is and then attempt to find the zero of this function. So we want to recall first what finding zeros are. Finding zeros can come under different names, but they're synonymous for the same idea. So we could call them x-intercepts. This is something that we might see from an Algebra 1 perspective. We see they're also called zeros of a function. They could be called roots of an equation. And sometimes they're also called solutions. So these are all telling us to do the same thing essentially, but in different contexts. So since we have a function, a proper context would be find the zeros. So how do we do this? Well, one of the first ideas you should have is kind of reducing this fraction or making it more of a proper fraction. So we have a rational function here. The degree of the polynomial in the numerator is greater than the degree in the denominator, so this is an improper rational function. So we can have some kind of procedure to put this in a more proper form. One thing you might try to do is factor the numerator, and you might try that, and there's factoring methods that you may have memorized. That may not be something that everybody has memorized, so in a testing situation, that may not be an effective route. The other option would be polynomial long division or synthetic division. I personally like the synthetic division, but I'm going to work through a route of polynomial long division. That's maybe one of the better known methods. So I have x plus 4 is going to be divided into x squared plus 16. And there's a lot of side work that's going to happen here. So I'm going to look at ratios of the first term to the first term. So the first term of the inside to the first term of the outside. So when I look at that ratio, it reduces to x. And so I'm going to take this term and put it as part of the quotient. And I'm also going to take this term and I'm going to multiply it by the number on the outside of the division bracket. And then I'm going to take this term and I'm going to subtract it from the term that is under the bracket. So I have x squared plus 4x, all in parentheses with a negative on the outside. This is a tricky part. Students end up with sign errors here because we have to distribute this negative. So this x squared becomes negative and this 4x is going to become negative as well. So I'm just going to come in here and make some changes. So I have x squared minus x squared is going to be 0, 0. There's essentially no x term up here. The coefficient is going to be 0, so I have 0 minus 4 is going to be negative 4x. And then I'm going to bring down the 16. And then I'm going to look at this term with this term in ratio. So I have negative 4x over x, and that reduces to negative 4. So that's going to become a part of my quotient, and I'm going to take that term and multiply it by this. And I'm going to take that term and subtract it from this. So I have two negatives here. Those are going to become positive when I distribute the negative. I'm just going to do that all as one step. 16 plus 16 is 32. This is going to form my remainder. So I'm going to have this. So now that I have f of x is equal to this, I'm going to set this to 0 and see what we can do with the x over here. So now I'm going to add 4 to both sides to move the 4. So I have 4 is equal to x plus 32x plus 4. Probably be good to move this x and get it all as one fraction. So I'm going to multiply top and bottom by x plus 4. So I'll have x squared plus 4x plus 32 over x plus 4. Now that I have this, this is a quadratic. All right, working through a lot of side algebra here, we see that we can factor the quadratic in the top into two factors that involve complex numbers. And so you can see some of my calculation over to the side here. So this is not going to give us a nice x value in the Cartesian coordinate system, but instead we're going to get some zeros in the Argand plane. For those who have some idea of factoring techniques, let's go back and look at a factoring technique. A squared plus b squared equals some product minus another product. So maybe that is what we're going to need. So we need to identify an a and a b. So the square term here, the square root of that is x. So our a is going to be x. The square root of 16 is going to be 4. So our b term is 4. And so if we subtract negative 8x over x plus 4 from both sides, we may have something that's usable. This can be rewritten as x plus 4x minus 4 over x plus 4. The f of x we're going to declare is 0. So we have this. We can multiply through by x plus 4 and end up with negative 8x equals x plus 4 x minus 4. If I divide by x on both sides, I have all my x's over there. It looks a little cleaner than what I got down here. This was our previous attempt. So what x can I plug into here to get negative 8? So this is a slight variation of what I had before. I had some complex numbers in my numerator, and I needed x to plug in to get a positive 4. So we haven't gained a lot other than a better looking rational expression. So one thing we might observe that in a fraction, if the numerator goes to 0, the entire value of the fraction is evaluated at 0. So if we're looking for something in the form 0 equals x squared plus 16x plus 4, we really only need to consider what sends the numerator to 0. We don't want to send the denominator to 0 because we can't have that division by 0. But then if the numerator goes to 0, then this entire thing is what we're looking for, because the numerator going to 0 means we have a 0 value. So let's just look at the numerator. Can we solve x squared plus 16 equals 0? Well, this is a quadratic. And so, yeah, we can attempt to solve this. So we are going to plug it into the quadratic formula. And our b value is 0, so we're going to have plus or minus the square root of negative 4 times 1 and 16 over 2. And so you'll see in here that this value is going to end up being a negative in the discriminant, and so we're going to have some, again, complex numbers. So we end up finding that the two x's that are going to make this 0 are plus or minus 4i. So let's check that. If we plug 4i into the original, we end up with 4i squared plus 16 divided by 4i plus 4. Division by a complex number is defined so we can carry out this process. If we square 4i, this is going to give us negative 16, so we're going to have 0 in the numerator and 4i plus 4 in the denominator. So let's multiply this top and bottom by the conjugate of the denominator, so that is 4i minus 4. So in the numerator, again, we are going to 0. In the denominator, we are going to have some real number. If we take 0 and divide it by a real number, we are going to get 0, and so this checks out. So we are looking for plus or minus 4i. So the zeros of this function are going to be plus 4i and negative 4i. Cheerful calculations.